Welcome to Calbekistan, a place where anybody can learn math. I'm Mr. Calbeck, and this is Solving Crash Course Episode 9. We're going to be talking today about something called a literal equation. And this is going to look weirder than anything we've done so far, but I promise once we're done with this video, it's going to feel easy. Let's get started. Alright, what we have here is called a literal equation. Literal equations just mean that there's lots of variables, and usually what they're going to say is you'll have a problem and the instructions will say something like solve for x, something like that. All that means is the same thing that solving has meant in all of the other videos in this series. Solving means to get the variable by itself. In order to solve this problem, we're going to need to remember some of the foundations of what we're doing when we solve. So first thing we're going to need to remember what a variable is. Secondly, we're going to need to remember doing the opposite. Thirdly, the golden rule. If you remember those three things, this is going to actually be remarkably easy for you. But it looks scary at first. So let's see if we can break down what this is really saying here. So if I want to solve for x, and I remember those three things, I need to remember that w and y are variables, which means they're just numbers. Okay, so let's remember that. Variables are just numbers. So before I get started on this problem, let's see what would happen if I replace those with numbers. Let's say w is equal to 4, and let's make y equal to 6. Now, I'm picking random numbers in here. I don't know what w and y are, but I want to see if maybe the process of solving this with x is going to make it easier if I just have numbers instead of variables. Let's see what happens. If I want to solve for x, I'm hoping you can all solve this after watching the crash course. I want to do the opposite. And right now, x is getting multiplied by 3. And remember, this just means division. It's not a fraction. It's divided by 4. So I want to do the opposite. Probably get rid of that division first. But it doesn't matter so long as you follow the golden rule. So I'm going to divide this x being divided by 4, so I'm going to do the opposite. Doing the opposite is just multiplication. I'm going to multiply both sides by 4. Remember, since the x is getting divided, that's where I multiply. So 4 divided by 4, remember that cancels out. But again, things don't cancel with division. They just divide into a big 1. 6 times 4 is over there. So that leaves me with 3x equals 24. This is an easy problem. Divide by 3 on both sides because it's being multiplied. Do the opposite. Okay, this is an easy problem if you think about it with numbers. Now let's see what happens if we do it with variables. All right, so I'm back to the variables here. Let's see if we can do the same thing, because remember, if variables really are numbers, that means anything we can do with numbers, we can do with variables. So what we did before is we multiplied both sides by 4, but now we've got a w. Is there any reason we can't multiply both sides by w? No, let's just do it. See what happens. Multiply by w over here, and anything divided by itself is 1. So that makes a 1, same exact thing as the 4. We'll multiply by w over here. So that leaves me here. Those w's have become just a 1, so I've actually gotten rid of one of the variables on this side. That leaves me with 3x equals y times w. Now, I don't know either one of those, so I'm just going to leave them as variables. Just like I don't know what x is, so I leave it as an x. I can do the same thing here. I'll do y, w. And I'll put the multiplication sign in there so I remember that they're being multiplied. You can't simplify, so don't simplify. Now it's being multiplied by 3 here. I'll do the opposite again. Divide by 3. Remember, I have to divide both whole sides. Remember the golden rule. That which you do to one side, you must do to the other side. Once you do that, you cancel that out, and you're left with your answer. X just equals yw over 3. And that's your answer. You don't have to simplify anymore because you can't. So circle that, put a box around it, you're done. I know this is going to feel a little bit weird, but that's all you have to do. Treat the variables just like you would numbers. The only difference is you don't simplify. And we're done. Let's look at a couple more examples. All right, in this one, I've actually added an additional variable here. I don't just have 3, now I've got 4. But you'll find that actually doesn't make anything any more complicated. So let's see what we've got going on here. Quick pro tip, by the way, I always put a slash through my z's, because if you don't, they end up start looking like 2's if you're being sloppy. So if you have a struggle with sloppiness as much as I do, put a slash through that z, and that's what's you never mix it up. All right, let's do the opposite. All right, if I had 4x plus 12, for example, I just subtract 12 from both sides. So that's what I'm going to do here as well. Only difference is I don't have 12, I have yz. All right? Now some of you might be tempted, because these are being multiplied together, to divide, because that's the opposite of multiplication. But remember, we only really want to do something with x. I want to get the x by itself. So I want to think about what's happening with these variables with relationship to x, and they're being added. So I'm going to do the opposite of that, which is subtracting. I'm going to subtract yz. Again, that looks weird, but remember, variables are numbers. I can subtract numbers, so I can subtract variables. I'm going to do the same thing on both sides because of the golden rule, which leaves me with 4x equals a minus yz. Now again, normally we'd be able to simplify this into one number, but because we have 3 variables, we don't know any of them, you don't simplify and you leave it like this. That leaves me with one more step before I get x by itself. It's being multiplied. I need to divide. And again, the golden rule says that you have to divide that you do the same thing to both sides, which means when I divide, be careful here, it doesn't divide by the a, it doesn't divide by the yz, it divides by the entire side. Be really careful there. It's a very common error. If you divide, it has to be the entire side. That's going to make a big 1 here, which leaves me with x equals all of this. Not bad? I hope so. We're going to do one more example. And again, remember, just think about the opposite. Do it to both sides. You're going to be in great shape. This last one looks particularly gross. I don't even have a single constant. Again, constant is just a name for a regular number. I don't have a single one of those in this problem. But again, all we have to do is think about the opposite. You can do this. So, first thing I see here is a big division. Again, it's not a fraction, it's a division problem. So opposite of division is multiplication. If this is all divided by z, and again I put that slash through it so it doesn't look like a 2, that makes a big 1. It cancels out. Over here, I got to multiply by z as well. Now what I'm left with, a times x plus y equals h z. Now there's a number of ways you could approach this next part here, but I'm actually going to think about this in the same strategy I used with fractions. When I had a fraction distributing here, I think that's episode 6, so you can take a look at that if you don't have one already. But this is all multiplied. The entire side is multiplied by a, so if I want to do the opposite, I can divide the entire side by a. And that's what I'm going to do. Since the whole side's multiplied and the whole side's divided, that divides into a big 1. And over here, I've got an a. All right? Now, once those are gone, I don't have anything left to distribute in here, so I can get rid of the parentheses. And I'm left with x plus y equals all of that. I'm almost done getting x by itself. I want to subtract the y because it's being added. And that just goes over here. And again, you can't simplify any of this because you don't know the numbers. That doesn't mean you can't actually solve it. So we're going to go ahead and put a big box around that, and you're done. Okay? We've got the x there, we've got our unsimplified variables there, and that's all you have to do with a literal equation. It looks scary, but I promise if you think about the same principles that we've been teaching in this entire series, do the opposite. Variables are numbers, and following the golden rule, that's all you need to do to solve even the grossest looking problems that I can come up with. You guys are going to do a great job. Stay tuned for some more bonus lessons if you want a preview of what you'll learn later in math class.